Hello and welcome everyone to today's session. How Siemens AG built an enterprise-wide data mesh architecture on Snowflake to enable supply chain use cases. Before we start to introduce ourselves, we would like to first introduce our company. So who is actually Siemens AG? Siemens AG is one of the biggest European manufacturing companies with many different lines of business, and we are committed to drive innovation and digitalization. Overall, we have more or less three main business lines. We have Siemens Smart Infrastructure, focusing on energy systems and smart infrastructure. We have Siemens Digital Industries, focusing on factory automation and digitalization, and Siemens Mobility, focusing on the train business. Overall, Siemens, or we as Siemens, also our CEO, Roland Busch, we have one vision. We would like to become a data-driven company. And to become a data-driven company, of course, we need to work with data in a new ecosystem. The issue what we're facing is, or what also our CEO Roland Busch is facing, is how can Siemens actually crack the code? And what does it actually mean? So overall, Roland Busch, our CEO, he says the big value of Siemens is how we can combine, let's say, IoT-connected devices, software, but also data in one ecosystem. So how can we revolutionize the way of how we work with data? So this means how can we combine IT and OT? How can we leverage the entire technology stack, meaning hardware, IoT-connected devices, all the data, but also software and the applications on top. And here comes the crux into the matter, because so far no company has achieved this to establish an ecosystem which scales in our industry. And especially in our industry, this is really challenging and demanding. So to become a data-driven company, we have a vision to create the Siemens Data Cloud, our new AI and data ecosystem of the future. To do this, we also follow the joint IT targets we have at Siemens, which is on the one hand side, SaaSification and digitalization. So to use SaaS products instead of on-premise or legacy systems, but also how we can, let's say, streamline overall processes and how we can also utilize all the knowledge of all the domains and the knowledge of all the people we have in our company. So this is more or less how we would like to become a data-driven company, and this is exactly the session today all about. So how we have used or established the Siemens Data Cloud as our new ecosystem of the future. But now let's also introduce us quickly. So it's a pleasure for me to speak today on behalf of Siemens. I'm Christian Meyer, I'm the head of cloud operations. I'm from corporate IT from Siemens, and I'm the chief technology architect of the Siemens Data Cloud.
Yeah, hi everyone, my name is Rebecca. I'm IT business partner, responsible for business intelligence topics at Siemens AG. I'm in business IT, working for the business unit Digital Industries.
Yeah, also welcome from my side. So my name is David. I'm working for Siemens since almost 18 years in different positions within IT. And for the last 2 years, I'm responsible for the business intelligence and data analytics topics within the business unit's factory automation.
Perfect. So in the next 40 to 45 minutes, we have more or less three topics. So first of all, I will like to give an overview of the so-called Siemens Data Cloud, our new data and AI ecosystem. And afterwards, Rebecca and David will present a real-world use case which is built on top of the Siemens Data Cloud. And last but not least, we have a short wrap-up. To start, I would like to share our vision of the Siemens Data Cloud. So the Siemens Data Cloud is an open data mesh platform ecosystem that allows to curate data products of any kind, which means BI, AI, and also ML data products, and to share those data products seamlessly across the Siemens data ecosystem. So this is now a vision with many buzzwords, and we heard also these buzzwords or data mesh quite often last year at the Snowflake Summit. So overall, our vision is that we create an open and flexible data ecosystem so that it's easier how to work with data, especially also to improve the time to market, to allow our data scientists or machine learning experts to easily access data and also to share then the newly generated data or information with other business units. And this is why we have created this mesh ecosystem. So it should be open, it should support all these domains we have at Siemens to easily work with data and also then share cross-domain data between the different units. This is exactly our vision, but of course I would like to also share some more insights how this actually looks like from an architectural point of view. and I will go together with you through the different layers of the Siemens Data Cloud and also explain our challenges and how we have set up the Siemens Data Cloud. So this is not a technical architecture, but this should represent more or less how we have established the Siemens Data Cloud as a data mesh architecture with with a lot of different domain mesh elements or different layers. And I would like to start from the bottom and going to the top to explain how this actually works. And if you have a look here at the data source layer here, we have a lot of different data sources at Siemens. And one of the biggest data, or one of the largest amounts of data we have, is the data which is structured data, which relies on all these different ERP systems. At Siemens, we have around 50 different ERP systems, and all the data from all the ERP systems must be transported, somehow replicated in almost real time to our new Siemens Data Cloud ecosystem. And this was one of our biggest challenges we had the last, let's say, 1.5 years to find a scalable and reliable solution which allowed us to replicate all the ERP data from all these different ERP systems distributed all around the globe to Snowflake. Finally, we found a solution, and we're using now S&P Glue as our solution to replicate all the data from all the ERP systems to Snowflake in real time. But in addition, we also have a lot of other data. So we have data from other databases, external data, IoT data, unstructured data, semi-structured data, so data from all these different domains. So what we have to do is to work with the data, we have to integrate the data somehow to the Siemens Data Cloud. So the second layer represents the integration layer, where we distinguish between 3 different integrations. The mass data ingestion for us is more or less how we can replicate data which is relevant for all different business units at Siemens, let's say from a corporate point of view, to the Snowflake. So here, as already mentioned, we are, for example, replicating ERP data via S&P Glue to Snowflake. But we also offer self-service integration capabilities and event-driven integration, like Kafka or Alteryx or Talent, so that also our business units have the capability to replicate data with their own tools or with tools we provide to Snowflake. The next layer now represents the domain mesh element layer, where we have 3 different, let's say, data clouds, domain data clouds, business data clouds, and region data clouds. And all these different domains, and I mentioned in the beginning, we have, for example, the different business units like Siemens Digital Industries or Siemens Smart Infrastructure, or we have regional requirements coming from the US or from China. All these different mesh elements build one component of the Siemens Data Cloud. They have flexibility how to work with data, but they are, let's say, integrated to our overall ecosystem. And this creates synergies and allows us to work with data in a more, let's say, integrated way. And really important here is that we somehow also have access to all the data which is domain specific, so that this data can be reused and shared. And this is exactly why we have established a layer how to easily reuse and share data using our global mesh elements, which you can see here on the top. So the top layer are 2 mesh elements layer, which we, let's say, provide from a corporate IT perspective, which is on the one hand side Snowflake, on the left hand side, our global sharing and cloud data warehouse layer, and streaming, where we use mainly Kafka to stream data in real time. Important here to say is that inside Snowflake, we have all the different domains. So all these different domains work in one single Snowflake account, and this allows us to easily share data and provide data to other units. In addition, we also have the metadata layer, where we have a data and API catalog. So this catalog is connected to Snowflake to get all the metadata out, so that we can also use a catalog to create the data lineage and also to share with all the units which data is actually available in Siemens and how this data can be requested. And to request data, we also established a new, let's say, end-user facing shop, so the so-called Siemens Data Cloud shop. The Siemens Data Cloud shop is our one-stop shop for platform and data requests, where end users can easily access data or request data, and everything what is underneath is fully automated. But I will come to an example later. Last but not least, we have also on the right-hand side different consumers and producers. So at Siemens, we have more or less almost every technology you can imagine how to work with data. So we have front-end tools like Power BI, Tableau, ClickSense. We have process mining tools like Celonis. We have ETL tools like Alteryx. We have low-code tools like Mendix. So there are so many different tools, and all these tools can now easily connect also to Snowflake to get the data out. This is a major achievement because we're coming from an old world where we had SAP HANA on-premise, one of the biggest SAP systems in the world. And right now we are migrating all the data from SAP to Snowflake and allow now our users to easily access the data and use all these new capabilities Snowflake provides. So we are not just, let's say, benefiting from Snowflake with the compute power they have, but we also have, let's say, a framework where we have isolated compute per project, where we can charge on a with a consumption-based model, where we can also integrate all these new capabilities like data sharing. So we're already using data sharing to share data with other entities, for example, Siemens Energy or also Siemens Healthineers. And this is just a starting point. So we really see the benefit here of Snowflake, how we work with data, how we share data, how we use this marketplace functionalities, and also how we can leverage the AI functionalities of Snowflake into this new ecosystem. And as we're here today at the Snowflake Summit, I would like to focus a little bit here on this part, because overall, Snowflake is really a key component of the so-called Siemens Data Cloud, and represents more or less, it is represented here more or less on the global measurement layer on the top. So what I would like to do now is I would like to share some more insights how we have set up Snowflake, so how we have done this so that this also scales at Siemens, where we have such a complex world with so many different business lines and, let's say, regional ITs and so on. So having a closer look into Snowflake, you can see that Snowflake overall is just one big account. So we have a global account setup. We as corporate IT, we are responsible for this account, and this one account is used by all Siemens entities we have at Siemens. So this means we have deployed this one single account setup with a framework where we provision automatically with pipelines projects which can be used then by our end users. So I mentioned already in the beginning, we have the so-called Siemens Data Cloud shop. If someone from Siemens would like to start working with Snowflake, they don't have to go to our Snowflake account management team and ask for a Snowflake account. They can just easily go to our Siemens Data Cloud shop. They can request a new Snowflake project. We have, let's say, automated processes behind, so that not just Snowflake is provisioned with an RBAC framework, but also underneath we deploy automatically in our codesiemens.com, so our private GitLab repository, some repositories, and we also have dbt Cloud, which we're using as a development workbench for all these projects. So this is really a nice experience right now for all our new users who would like to start working with Snowflake, because they don't have to worry about contracts or how to deal with data security or privacy, because this is already managed centrally by corporate IT, and it's really easy to get started with Snowflake. As I mentioned, also security and data privacy. So we as corporate IT, we have ensured that this entire framework of this one single account setup is built in a secure way. So we are taking care of technical user requests, of storage integrations, of networking policies. We went through together with our partners at Siemens, with our cybersecurity experts, with our data privacy experts, through all the different requirements we had to get, let's say, the final rating that we can also use this account setup and this framework for all Siemens at this scale with all the data we would like to integrate. We also take care of data sharing requests. So we as corporate IT, we work on these automated processes and provide these to all our projects who would like to start working with Snowflake, so that they can really start working with the data and on their use case, on their business problem, instead of focusing how Snowflake can actually be used or set up. And I already mentioned this one. So we have a DevOps framework in place, which allows our end users to easily start working with a fully integrated GitLab repository and also dbt Cloud. On the right-hand side, I have also, let's say, a high-level overview of the architecture of this one single account setup. So we have here different, let's say, areas. We have the landing area, we have integration area, we have a modeling area, and also sharing layer. And what we had in mind when we started with Snowflake, we wanted to have a framework which scales easily, so that we can also easily onboard new projects. So right now we already have many, many different projects, and they all are, let's say, built on the same framework. They get an isolated project where they have out of the box 3 different environments, a dev, quality and production database, and all these projects are completely isolated from all the other projects. This means they are isolated regarding compute, but also regarding charging. And this allows us to also charge all our projects on a monthly basis, consumption based. So whatever a project is consuming, we can easily evaluate end of the month and we can automatically charge out the projects. So this is also a fully automated process we have in place. Important to mention here as well is the sharing layer, which you can see on the right-hand side. So data sharing is really important for us, and data sharing also has a lot of requirements inside Siemens. So who is allowed to see what data? Who must approve a data request? What about row-level security, data masking policies? And with this sharing layer on the right-hand side, we have established more or less a layer where no data is persisted, but where we manage the grants, which project is allowed to see which data. So whenever there's a project from a different domain, so for example, here in the sales data cloud, a project is creating a new data product. They have the flexibility to also publish a view in our so-called sharing layer so that other projects can easily request then this new data product in our Siemens Data Cloud shop to have access to the data. And exactly this process, which we are working right now, or which is already implemented in our first version, but what we are improving as well, is what I would like to explain a little bit more detail by going to the Siemens Data Cloud shop. Before that, just some KPIs, how big our ecosystem already is. This is from April this year, but we already increased quite a lot since April, so this is not the latest information. We have right now more than 220 terabytes of data. We have more than 50 ERP systems in live replication to Snowflake, but this is just ERP data. We have a lot of other data sources which are also connected. We have around 5,000 warehouses up and running. We have more than 3 billion changes we are processing per day coming from the ERP systems. We have not 28,000 rows. I think we have almost 40,000 rows right now in our account. And we already have more than 600 projects. And these projects are all over the different business units. So Siemens Mobility, Siemens Smart Infrastructure, Corporate IT, Siemens Digital Industries, they're all using and working in the same account. And of course, this creates now synergies because all the data is one account and all these projects from all these different business units are also working in the same account. So we can leverage all our data sharing capabilities we have built so that they can easily work with data. And this is exactly what we're doing with the Siemens Data Cloud shop. So the Siemens Data Cloud shop is our one-stop shop to buy and request data assets. So as an end user, you can easily go to the Siemens Data Cloud shop and you can request not just data, but also platforms. So after the user went to the Siemens Data Cloud shop, he can, for example, request access to specific ERP data or to C-sales data or whatever data. Depending on the configuration of this data product, we automatically have an approval workflow in place so that the owner also must approve this request. And this is configured with row-level security. So based on the country you select and the business unit, a different approver must also approve your request. After everything has been approved or also rejected, based on the outcome, we also trigger then the provisioning. In the easiest example, so you're a Snowflake customer, you're working in the Snowflake account, you're requesting data from sales, you're from finance, we can easily grant the permissions inside Snowflake. This is more or less done out of the box immediately, and you immediately have access to the data. The good thing about this, as mentioned already, we can also immediately record a payment and also, let's say, charge our customers based on the data requests. So also monetization features are included. And this actually only works because we have fully integrated here the Siemens Data Cloud shop with the metadata coming from a data catalog and also from Snowflake, and in addition from a Mendix tool, which we're using to configure these data products with row-level security so that it's easier for our end users not to work only in Snowflake, but to have a guided, let's say, workflow how to create such data products. Having said this, I would like to hand over now to David and Rebecca, who would like to share some more insights of one real-world use case on the Siemens Data Cloud.
Yeah, right. So thank you, Christian. So from the concept and some overall figures, I'd like to present one of our, I think, actually first use cases we implemented with Snowflake. And it's our supply chain use case. Before getting into the use case details, I'd like to give you just a brief overview about our businesses and services, as Christian already mentioned. So Siemens offers a wide range of different products, and we have Siemens Mobility, Smart Infrastructure, already mentioned. So Rebecca and myself, we are part of the Digital Industries and in the business unit Factory Automation. And there, as you can see, we are producing electronics equipment to automate and digitize the factory and manufacturing sites. And as you can see, we are number one market position globally in the factory automation business. And just maybe to name two highlights. So the Simatic PLC, so that's basically the controller to control and steer all the electronics equipment within the factory, like robotics equipment, for example. Another example would be the Simatic HMI, so the human machine interface, basically also built for industrial use as well. And the visual interface between the human and the machines within the production sites. So basically, what is the use case about? So within the factory automation, we have three major production sites. Each production site uses about 10,000 raw materials for production. And the business requirement was to stabilize the supply chain and reduce the production outages, and therefore come to a solution to calculate a risk score for each single material, so raw material or components we are purchasing, and calculate a risk score on which basis we would build up or level the safety stock. And basically that's always a challenge to balance between material availability and a stable production on the one hand side, and on the other side, of course, low storage costs. And to find the optimum between stable production and low storage costs, that was basically the business requirement we were facing. And just for better understanding, so this project was focusing about short-term risk, but of course there are other projects going on more with a mid-term or long-term perspective. For example, reducing single source components, or maybe even change the product design to reduce critical components. So what was the project goal? So as already mentioned, first project goal was really to reduce number of production outages due to material shortages. But at the same time, we wanted to reduce the storage costs. So we wanted to identify those components with a low risk and therefore reduce the safety stock for those products. But as it was one of our first projects using the Siemens Data Cloud and also Snowflake, of course, it was also the goal to explore the Siemens Data Cloud and identify the potential and the usage for all different kinds of BI and data analytics requirements we have. So what were the different project steps? So basically, first of all, together with the business colleagues, we had to identify influencing factors on the material risk. And second, we had to connect all those source systems to the Siemens Data Cloud. So as we were just starting this project, Siemens Data Cloud, not everything was connected. So therefore, that was the first step, to bring all that data into the Siemens Data Cloud. But of course, following projects will gain from that and easily use also those data for other use cases. Third, we had to implement the calculation logic to really to calculate the material risk on a raw material level. And then afterwards, we wanted to implement a fully automated process. So therefore, we also had to write back those results to the ERP system to really manage and build up the safety stocks in the different ERP systems relevant for us. So basically, how does it look like? So what are the different risk factors we are considering? Basically, the material risk is on a score from 0 to 5. So 0 would mean no risk at all. So we would reduce the safety stock, and 5 would be the highest risk. So that would mean build up a safety stock to have a stable production in case. And basically today, we have set up the system that way that all materials with a risk score from 3 to 5 would be considered for a safety stock. And this information will be transferred in the ERP systems. So which factors do we consider? So just to name maybe some examples. So we have purchasing risks. So as already mentioned, for example, materials where we only have one supplier, of course, we have a higher risk. Therefore, we would build up a safety stock. Delivery risk, there we have different topics we consider. So for example, how do our suppliers meet our requested delivery time? So do they always deliver on time, or even how flexible are they when we are shifting those delivery times? But also in this delivery risk category, we also have some external data, like this inventory risk. So there we get external data about the availability of standard materials. So are those materials available on the market from distributors, for example? So that's also one factor we are integrating into our calculation. And then, of course, we have quality risks. So when we have materials with a lot of complaints, therefore, of course, the risk is also higher, and we would also build up a safety stock. So all those figures or factors will be considered for this risk calculation. And as you can already see, so we have different kinds of data sources connected. Most of the data is coming from the ERP systems, but we also have other data sources like the external one already hosted on AWS. And we have also some local databases like the Oracle databases we are using to get some quality insights on the material level. And basically to get into more detail regarding the technical concept and also the architecture, I would hand over to Rebecca.
Yeah, so thank you, David, for the introduction to the business case. I would now like to go into some more technical details and explain to you which elements from the Siemens Data Cloud we used to implement the project. So as you've seen on one of the previous slides, we used 3 different data sources for the calculation. The first data source was SAP ERP data. You can see this in the actual sketch here, the top. We rely on the centrally provided service of the ERP data replication into Snowflake. So for our project, we can grab the data directly from another Snowflake project from the sharing layer. The second data source is a local quality database. It's an Oracle database that's in one of our production plants. So to get this data to the cloud, we use the ETL service Talent to bring the data to an S3 bucket. The third source we have is third-party data that's provided to us in an S3 bucket, and we use bucket replication to get it into an S3 bucket from our project. To get the S3 bucket data then to our Snowflake project, we use Snowpipes, and then the calculation of the risk factors and also the final risk score is happening in our project. When we are done with the calculation, we expose the final views to the sharing layer that Christian was also mentioned earlier. From there, we can share it with other Snowflake projects, but also with our front ends. So we have a visualization in place in Tableau, but also one of the most important tasks of the project was to bring the data back to the ERP system to be able to automatically calculate the safety stock. So for this, we use NIME as an ETL tool and SAP PI, which is a software tool by SAP that helps to bring external data into the ERP system. We also have an email service in place on our Snowflake project, so we can send out notifications when the data is not correctly inserted into our tables, so we don't miss errors that are occurring. Okay, so on this slide you can see in our architecture what elements from the Siemens Data Cloud we used. And now I would like to go into a little more detail on our data pipeline within our SCM risk identification Snowflake project. So here you can see the data pipeline that we used. In the middle you see our Snowflake project, and we have a 4-layer structure. We have the landing layer, the staging layer, the integration layer, and the modeling layer. And all those layers are modeled as schemas within our project. As you've seen on the architecture slide, we have data coming into our project area through S3 buckets. So to bring this data into the Snowflake project, we use the service of storage integration to manage the access between the HWS account and our Snowflake project. And we use an external stage to create the connection between those two locations. Then the Snowpipe brings the data into our landing tables each time a new file is uploaded to the S3 bucket. Our landing zone functions as a pure drop zone for the data, so there are no transformations done in this step. So we take the data from there and bring it directly into the staging layer. How we do this? We have streams listening to each of the landing tables, and once a day we have tasks running that then insert the data from the streams into our staging tables. Then the landing tables are cleared out so that they are empty and waiting for new inserts from the S3 buckets. The staging layer is, so to speak, our persistence layer for the data. So we have the data lying in tables there, and from there, downstream the project, we only use views to transform the data and to do our calculations. So on the integration layer, we calculate the individual risk factors that you've already seen, so the 8 risk factors we have. And then on the modeling view, we calculate the final risk score and also create the views that we then expose to the sharing layer for our front ends to grab. Okay, so let's see how this data looks like in our visualization. So you can see here 2 screenshots from our Tableau dashboard that we have in place. On the left-hand side, you can see the distribution of the risk scores of our plant in Amberg in Germany. On the right side, you see for one example material at the very top, the risk factors, so how the final risk is composed out of the risk factors. And below that, you can see the history of the risk factors, so you can see how the risk changed over time. And this visualization is really crucial for our project because the logistics planners, when they are skeptical about one material or about our calculation approach, they can go into the Tableau dashboard and check themselves how the final risk is composed. So it really helps to gain the acceptance for this data-driven approach and for the calculation. So to wrap it up, we would like to provide a short review of the project. So from a technical point of view, I can say that the project implementation was really successful. As David already said, it was the first project that we did in our business unit using the Siemens Data Cloud. And we were amazed how easy it was to integrate the different data sources and how we could use the sharing layer, and everything was already in place and ready to use, so we could focus on the business case. Also, the project proved that the Siemens Data Cloud is scalable and that we are confident to use it for bigger projects in the future that we are already implementing at the moment. For our business, it's probably the most interesting that also the operations costs are lower than the benefits the business is gaining. But for sure, as it was the first project that we implemented, we also had challenges. For example, one big challenge we had was the deployment and also the collaboration, because as we already said, it was one of the first projects, so the technology stack of the Siemens Data Cloud wasn't that big at that time. So we were developing only with the Snowflake worksheets, which was a little struggle sometimes. And also there was no process in place to bring the database structures from development to production. But nowadays for the projects we are currently implementing, we have dbt and the CI/CD pipeline in place within the Siemens Data Cloud, so these challenges are solved and we can develop even better. Okay, then I would like to hand over back to David for the business case review.
Yeah, right. So also some information about the business impact we made with this project. So basically in the past, the process was really experience-based, so it was a lot of manual work, and you can imagine that was also not scalable. So basically it was not possible to do this process for all the materials and also not very, very frequently. So due to high costs, of course. And today we really have this data-driven process. So therefore it's also really scalable. So we already rolled out to 2 of our 3 plants. The last one in Fürth is coming up soon. And yeah, it also helped us really to build trust in those data-driven processes, because as Rebecca mentioned, we also provide all those data. We are calculating all the steps within this calculation. We are providing with this Tableau report also to the users, and therefore we also build trust in those processes, because we make all the results and data available in this Tableau report. And therefore all the decisions can be easily tracked and also understood by the logistics experts. Yeah, well, also more stable production. Basically, for those of you who would like to get some numbers, that's really difficult at the moment, also due to the delivery crisis, for example. So it's difficult to really get numbers of the impact. So therefore, at the moment, we cannot show those. But definitely, we also have the business response that the process is working, and it has a positive impact on the production and also on the storage costs. But no figures available at the moment. So basically, having said that, so I think we are at the end of our presentation. So there was no Q&A planned today in this audience, but of course you have the chance to meet us also outside afterwards, get in contact with us. And of course, we would be happy to answer more questions or get into more discussions with you. So yeah, thanks a lot, and have a good conference.
Thank you.